Alright, welcome to the Unit 7 review. This video may be a little bit long, but I figure since it's the review, you can pause it or watch the parts you need or don't, or just put it on a loop while you're at home so that you can just hear my voice in the background and feel comforted and safe. Let's go ahead and start. The beginning section is all the trig stuff. Although with this problem, for example, on number 1, you can use trig or you can use your knowledge of special right triangles. I'm going to go ahead and use trig. Make sure your calculator is set up in degrees, not radians, although if you've made that change, you should be good to go. So here's my calculator ready to go. Let's see. For x is, I'm going to work with the 30. X is opposite and 12 is adjacent. So I'm going to use the tangent of 30 equals x over 12. And then to find y, I'll use the cosine of 30 equals 12 over y. Okay, I'll go ahead and do both these calculations. For the first one, tangent of 30 times 12 is 6.928. I'm going to go ahead and round to 2 decimal places. It doesn't say on the review. You should do whatever you want. We've rounded to 1, 2, and 3, also known as tenths, hundredths, and thousandths. Make sure on the test you read the directions and listen to your teacher, who will probably read the directions to you, so you can round to the correct spot. So I'm going to round to the hundredths. So this is 6.93. And the cosine of 30 equals 12 over y. I'm going to have to divide here. This is 12 divided by the cosine of 30. And that's 13.86. Alright, let's take a look at number 2. The length of the leg opposite of the 30-degree angle of a 30, 60, 90 triangle is 2. This one, just for the sake of practicing, I'm going to draw the triangle. Look at that, that is gorgeous. 30, there's the 90, there's the 60. The leg opposite the 30 is 2. Just for grins here, I'm going to go ahead and use special right triangles, and I'll leave this one in simplest radical form. There's the relationships, 1, 2, square root of 3. The short leg is 2, so I know the hypotenuse is 4, and I know that the long leg is 2 times the square root of 2, or excuse me, 2 times the square root of 3. So the length of the side opposite the 60, that's 2 times the square root of 3. Then the length of the hypotenuse is double the short leg, so that's 4. Number 3. Find x and y. Well, this is an isosceles right triangle, so x is 10. And then in a 45, 45, 90, the hypotenuse is just the leg times the square root of 2. So y equals 10 times the square root of 2. Easy enough. You can use trig for those also and get decimal answers, but that was easier for me. An isosceles right triangle has a hypotenuse of 13 feet. So let's draw our triangle. That's better. We know that the hypotenuse is 13. We know these are congruent. Just for practice, we'll do this one in simplest radical form too. This is 1 square root of 2. So this is what we're looking for, and we know this is 13. We end up with x equals 13 divided by the square root of 2, and then we rationalize that fraction, and we get 13 times the square root of 2 over 2. Find the missing side. This is a problem that I think most of your teachers were surprised that you missed. If you missed this one on the last test, this is just a Pythagorean theorem problem. Okay, this is just a squared plus b squared equals c squared. So I'm going to go into my calculator. I'm going to subtract 64 from both sides and get 105. And then I'm going to take the square root of 105. And 10.25 is the answer. Again, another Pythagorean theorem problem. So this is a squared plus b squared equals c squared. So the square root of 34 is 5.83. Use diagram. Use the diagram to find here. This is a question that's just asking for the ratios. Okay, we're not asking for x. It doesn't say solve for x. It just says find the tangent of x. So the tangent of x is, let's label our sides, opposite, hypotenuse, and adjacent. The tangent of x is 3/4. The sine of x is 3/5. And the cosine of x is 4/5. Really important that when you're taking the test, you answer the question that is being asked. All right, here's a bunch of trig practice. Let's label our sides. That's opposite, that's adjacent, that's hypotenuse. Let's remind ourselves of Sacagawea's half-sister SOHCAHTOA. And we have cosine. So the cosine of 31 is x over 14. Easy enough. Cosine of 31 times 14 is 12.00. Now I'm going to write, you'll notice, this is where your teacher might be really specific with your rounding, like I am with my students. If we say round to the hundredth, then the answer is 12.00034221. Then when we round to the hundredth, we need to know that you rounded. We need to know that this is x equals 12.00. If you write x equals 12, you're implying that you didn't round, and you did here. So especially if you're one of my students, make sure you include the correct decimals. Here we are saying solve for x, and you have all three sides, so you can use any trig function you like. I'm partial to tangent myself. So we'll say the tangent of x equals 15 over 36. Anytime I'm looking for the angle, I'm going to use the inverse trig function. So on the Casio, that's shift tangent. On the TI, it's second. And then on the Casio, I'm going to use 15 and the fraction button, and 36 on the TI, it's just in parentheses, and you'll just divide them, and then end parentheses. So here we have 22.62 degrees. Number 10. The measure of angle B is 90, and the sine of angle A is 1 over 2. What is the cosine of A? This looks like a hard problem. It really does. But it's not if you draw it. Okay, so let's draw a picture. So here's my triangle. And then labeling it correctly is a big deal. So B is the 90. So there's B. Here's A. And here's C. It says the sine of A is 1 over 2. Okay, that means that the opposite is 1 and the hypotenuse is 2. Then it wants to know the cosine of A. Well, that's going to be this side over here over this number right here. So I'm going to figure out what that is. I can do Pythagorean theorem really easily and figure that out. So we have x squared plus 1 squared equals 2 squared, which is 4. So x squared equals 3. So x equals the square root of 3. Now I left it as a radical because all the answers, the multiple choice answers, are in radical form. So the cosine is adjacent over hypotenuse, which is square root of 3 over 2. So the answer is D. Pretty easy problem. Number 11, this is a problem where it's, I got to figure stuff out in order. What order? Not always alphabetical. I got to look at the problem and see what do I know. Like I can't solve for x or y on this triangle because I don't have any sides. I can't solve for y or z because I have no sides here. The only triangle I have a side is this bottom one. So I'm going to solve for z first. Z is the opposite and 7 is the adjacent, so this is the tangent. The tangent of 40 is z over 7. Okay, so z equals z equals 5.87. Alright, now once I have this as 5.87, I can use tangent again, say the tangent of 50 equals y over z. Now I know z is that. So y is tangent of 50 times 5.87. 6.995 means that y is 7.00. And then here, this is the hypotenuse of this triangle, so I'm going to use the cosine of 30. This is the adjacent, that's the hypotenuse, so x over 7. So it's the cosine of 30, and that is 6.06. All right. Let's take a look at number 12. Let's label these. This is adjacent, this is hypotenuse, so I'm using cosine. The cosine of x equals 9 over 15. Anytime you're looking for the angle, it's the inverse. That's 53.13 degrees. Alright, let's take a look here. This is tangent, this is opposite and adjacent, so the tangent of x equals 4 over 1. Tangent's the only trig ratio where it can be greater than 1. So we're going to do shift tangent of 4. And that's 75.96 degrees. Alright, which two trig equations could be used to find x? So which two? So first I know that if this is 23, then this is 23 down here. So let's just go one at a time and see what works. Alright. So let's see, the sine of 23 equals 210 over x. And x is this side right here. Well, this is opposite and this is adjacent. So sine, we don't know anything about the hypotenuse, so that's not going to be an answer. The tangent of 23 is 210 over x, that works. And then the tangent of 67 is x over 210. Where is this 67 coming from? Well, this is a right triangle. This is 90, that's 23. That means that this angle up here is 67 degrees. This one works. Let's see if there are any other answers. Cosine of 23. We instantly know cosine is not going to work because it's going to require the hypotenuse. Tangent of 67 is 210 over x. Well, tangent of 67 would be opposite over adjacent, so that would have to be x over 210. So that's also wrong. So B is the correct answer. 2 pages down. You're doing a great job. You should be really proud of yourself. If you haven't paused the video to go get yourself like a snack pack or a fruit by the foot or something to keep your energy up, you should really do that. Find the angle of elevation of the sun when a tree that is 8 feet tall. Little known fact that in Empire Strikes Back, Yoda at one point actually eats a snack pack. It's the chocolate vanilla chocolate kind. He eats them one layer at a time. It's a Jedi trick. Alright, so here's my tree. Here's the sun. Okay, and we're looking for the angle of elevation for, let's see, let's move this all up real quick. It's kind of cluttered. Find the angle of elevation of the sun when a tree that is 8 feet tall casts a shadow that is 10 feet long. And we're looking for this angle right here. So that is tangent. The tangent of x equals 8 over 10. The hard part about these problems isn't really any of the math that we do, because it's the same math that we've been doing. It's just setting up the drawing correctly. Students make mistakes like putting the shadow as the hypotenuse and things like that, which if your shadow is a hypotenuse, it means you're probably a really oddly shaped person, and your shadow doesn't know where it's supposed to go. 38.66 is the answer. Joanna wants an 8-foot ladder to reach a window that is 6 feet above the base of the wall. So there's the 6 foot, the window's up here. We want the ladder to reach that. It's an 8-foot ladder. How far from the base of the wall should she put the ladder? Okay, so we want to know what's this distance here. She wants an 8-foot ladder to reach a window 6 feet above the wall. How far should she put the ladder? We're looking for this distance here. There's no part of this question that asks for an angle. This is just a right triangle, and we're missing a side. So this is a squared plus b squared equals c squared. Alright, well, that's not right. Sorry about that. Plus. Okay, so we get x squared equals 64 minus 36 is, if you said 28, you're correct. If you didn't say 28, get faster on your calculator. And then the square root of 28 is 5.29. And for Miss Ottinger's for her sake, and fate maybe, we'll put feet. She likes that. A ladder is mounted. This is my favorite problem, perhaps of all time, because I get to draw a fire truck. Uh, I always wanted to grow up and draw fire trucks. Life's ambition. Look at that fire truck. That's the siren. So a ladder is mounted on the fire truck that is 8 feet above the ground. Okay, so we're gonna on my fire truck, the ladder literally comes out of the siren. It's a really cool truck. Okay, and that distance right there is 8 feet above the ground. If the maximum length of the ladder is 120 feet and the maximum angle that it can be raised is 68 degrees, how high up on a wall of a burning building will that ladder reach? Or I guess the building wouldn't have to be on fire if the firemen just wanted to climb the building and like play capture the flag or something. So we're looking for this total distance. Now this is a good problem because first, the only distance we can find at first is this, and then we're going to have to add that 8 feet from the fire truck back to it. That's all. So we're going to say the sine of 68 equals, my handwriting today is extra good, so you are welcome. The sine of 68 times 120. The noise you're about to hear is a microwave oven. Can you hear it? You can't because it hasn't started yet. Wait for it. There's the buttons. 111.26. And then we have to add that original 8. Okay, so the answer, the height that it can reach, is 119.26 feet. All right. Another ladder question. A 30-foot ladder resting against a building. So here's my ladder. Makes a 50-degree angle with the ground. Find the height from the ground at which the ladder touches the building. So just this height right here. So that's sine. The sine of 50 is h over 30. Like I said, these problems, once you set them up, it's just the same stuff we've been doing. 22.98. Amy is flying a kite. The kite string makes a 35-degree angle with the ground. There's her kite. Her parents don't love her enough to get her like a butterfly or a dragon, so she just gets the boring regular kind. Maybe if she were a better student or a better daughter, they would have got her a better kite. Amy's 122 feet from the point on the ground directly below the kite. Find the length of the kite string. Okay, so this distance here. So this is cosine. The cosine of 35 equals 122 over x. Now variable on the bottom, remember that means we're going to divide. So 122 divided by the cosine of 35 is 148.93. 148.93. Alright. Two buildings stand 90 feet apart at their closest points. Buildings don't really stand, I don't think, unless they have legs. So they're 90 feet apart. So this distance right here is 90. One of the buildings is going to be taller. Because as we all know, taller is better. At those points, the angle of depression from the taller building to the shorter building is 12 degrees. So from here to here, and then the angle of depression, remember, is starting at the horizontal and going down. And I know that I'm going to have a right triangle, so I'm going to go ahead and put that in. And then this is also 12. And that is 90. How much taller is the building? Well, we're looking for that right there. And this is tangent. The tangent of 12 is x over 90. Tangent of 12 times 90. 19.13 feet. Alright, let's move on. So that's it for the stuff from this unit. The rest of the review will be review stuff. Stuff from previous units that you need to remember. So sum of interior angles of a regular polygon is n minus 2 times 180 to find the sum. And in this polygon we have 5 sides. 5 minus 2 is 3. 3 times 180 is 540 degrees. To find 1, we just divide that by the number of sides. So 540 divided by 5 is 108. I did all that math in my head because I'm a math teacher, and that's the only way you're able to multiply those large numbers in your head. Find the sum of the exterior angles of a dodecagon. The sum of the exterior angles of every polygon, no matter how many sides it has, is always 360. There's no math to do there. You just have to know something. To find the measure of one exterior angle of an octagon, it's the total degrees divided by, which is 360, divided by the number of sides. 8 divided by 360 is 45. Again, I did that in my head. My mom is proud. You should be too. Find the number of sides of the regular polygon with an interior angle of 120. Also classify the polygon by giving its name. I think this is easier to do using the exterior angle formula. So if the interior angle is 120, the exterior angle is 60. 360 divided by 6 is 6. And a 6-sided figure is a sixagon. Just kidding. It's a hexagon. That was a good one. You guys don't know this, but I just had to pause the video. Mr. Finn was in here, and it was getting really weird. He was starting to talk about his old days as a car thief. For those that don't know, Mr. Finn at one point stole cars from people for money. All right, so find the value of x. The figure's not drawn to scale. I'm going to add up each angle. All right, making sure that I've added all 6 of them. And then I'm going to set it equal to something. If you can't remember the formula for how to find the sum of interior angles, remember you can always just divide the shape from one point into triangles. And you know that a triangle has 180 degrees, and then this shape has 4 triangles, so the total number is 180 times 4, which is 720. I'm going to combine all my like terms, so I have 2x, x, 2x, and x, so that's a grand total of 6x. And then 115 plus 25 is 140, plus 160 is 300. Check my math here. 115 plus 25 is 140, plus 160 is 300, equals 720. I'm going to subtract 300 from both sides to get 420. 6x equals 420. There's that. 70. Alright, so x equals 70. Determine if the triangles are similar, or if so, blah, 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 all this stuff. The biggest mistake you guys make on this is that you don't give us the postulate, you don't give us a similarity statement, or you don't give us the similarity ratio. So you don't give us all the parts that we want. So if it's similar, make sure you give all the parts. Easiest way to tell, I'm going to list the sides of the larger triangle. And then under here, I'm going to list the sides. And I went large, medium, small. So I have to go large, medium, small again. And then these ratios should all be the same if they're similar. 15 over 8 doesn't equal 2, which these both do. So this is not similar. And then it says explain why not. The sides aren't proportional. All right. In triangle RST, whoa. So let me draw that triangle. I'm just gonna let's get a little bit neater with our work here. We'll just draw a triangle, and I'll draw another one. All right, triangle RST, and these aren't drawn to scale, but that doesn't really matter. It just gives me something to work with. RS is 3, RT is 7, and angle R is 47. In triangle VWU, VW is 21, VU is 49, and V is 47. So the angles are the same. And then I can look at this and see that 3 times 7 is 21, 7 times 7 is 49. So these are similar. All right, so first a similarity statement. Triangle RST is similar to triangle. And it's important that I go in the same order, that the corresponding sides and angles match up. So because I went RST, I'm going to put UW or VWU. VWU. They're similar by side angle side. The similarity ratio from this one to that one is 1 to 7. Okay. There's that. Mr. Kiley, Mr. Kiley decided that he wanted to know the height of the Statue of Liberty. Why he decided that is we have no idea. Because there's no reason to care. But pretty easy. These are similar triangles because of angle, so their sides should be proportional. So x over 152.5 should be equal to 6 over 3. The number of people that miss this problem, guys, look, Mr. Kiley, we're saying that he's 6 feet tall and this is 3 feet. 6 is double 3. All you have to do is double 152.5, okay, which is 305 feet. Here, we're telling you that the two sides of the two triangles are similar, and we want to know the perimeter of triangle DEF. Now, I know that this is 10 and that is 6. That means that this triangle is smaller. Whether it looks like it's smaller or not, it doesn't matter. It's smaller. So 10 over 6 should equal 12 over EF, and that should also equal 18 over DF. And then I'm just going to cross multiply to get some answers here. 6 times 12 is 72. 72 divided by 10 is 7.2. And here, 6 times 18 is 108. 108 divided by 10 is 10.8. 10.8 plus 7.2 is 18, plus 6 is 24, so the perimeter is 24. Find the value of y. Well, these two triangles are similar because of angle. 8 is double 4, so y is going to be double this hypotenuse right here. I use Pythagorean theorem. I can find that that is 5. 5 doubled is 10. Which figures will tessellate? Assume all regular unless the definition of the figure makes this impossible. Heptagon, 7-side, doesn't tessellate. Octagon, doesn't tessellate. Right triangle, does tessellate. Decagon, does not. Make a tessellation with the figure below. This is going to be really difficult for me to do freehand. If you have access to a ruler, if you want to get the question right, it's probably in your best interest to get a ruler so that this doesn't look terrible. Now, mine doesn't look great, but I am proving with my answer that I know what a tessellation is. They're all going to have the same number of sides. They're all going to be roughly the same shape, and I can tell that I know that that shape tessellates. Find the value of x below. The vertex of any tessellation is 360 degrees. It's easy to remember because I can put a circle around it, and the circle has 360 degrees in it. So 360 equals 3x plus 3x plus 2x for a grand total of 9x's. And then plus 20 minus 10 is 0. 9x equals 360, x equals 40. Label each statement as true or false. All triangles tessellate. True. All quadrilaterals tessellate. True. All hexagons tessellate. False. Regular hexagons tessellate. Okay? Not all hexagons. Explain why a regular hexagon will tessellate, but a regular heptagon will not. And the answer is that one interior angle of a regular heptagon is not divisible by 360. Okay? So one interior angle of a heptagon is not a factor of 360, because we just said at every vertex of a tessellation it's 360 degrees. Make a tessellation with the figure to the left. This is literally, like, we are literally asking you to play connect the dots on a test. When you guys complain about how hard geometry is, please know that on this test we asked you to connect the dots. This is a game that you play while you're waiting for your clucks and fries at Red Robin with crayons. Slope, distance, midpoint. This has been on every test. It'll continue to be on every test. You're hurting our feelings when you don't get this right. I'm going to make a quick sketch just to help myself. -2, 4, 6, 9. The reason I do that is so that I know this line is positive in nature. So the slope is going to be positive. The difference between the y's is 5. The difference between the x's is 8. That's the slope. That also helps me with distance. The difference between the x's, distance is the square root of the difference between the x's squared, so that's 64, plus the difference between the y's squared is 25, so this is the square root of 89. The midpoint is the average, negative 2, midpoint, point, it's going to be a point. The average of negative 2 and 6 is 2. The average of 4 and 9 is 6.5. Find the equation of the line perpendicular to this through that. Okay, you got to know that perpendicular means opposite reciprocal slope. So we have 4, that's the y value, equals the new slope times the x value plus b. We don't know the b of the new line. So 4 equals 2 plus b, so b equals 2. Now I can write y equals negative 2x plus 2. The midpoint of this segment is negative 2, 4. One endpoint is 3, 6. So find the new endpoint. From 3 to negative 2 is down 5. So I'm going to go down 5 more all the way to negative 7. The midpoint, the difference between 6 and 4 is down 2. I'm going to go down 2 more, and that puts me at 2. That's your answer, and that's the review. Please study. Please come prepared. Please do well on this test. It's the first test of the second semester, and you need it. Have fun, kids. Buckle your seatbelt, and don't drink or eat too much Red Dye 40. It's bad for you.